Hello everyone. So in this video we are going to learn about load balancer. So in the AWS we have a load balancer that is called Elastic Load Balancer. Now load balancer basically to distribute the incoming traffics uh, uniformly to all the workloads so that the performance can be enhanced. Already we have seen in the previous video that how to make use of uh, classic load balancer. Classic load balancer was earlier much used, but now we have more advanced form of load balancers like application load balancers are there, network load balancers are there, gateway load balancers are there. So in this exercise, we are going to see that how the application load balancers are to be used to manage our applications efficiently. So load balancer, as you know, as the name suggests, it is balancing the load. It is balancing the incoming traffic and distributes the entire traffic to to the various servers so that only one server cannot be kept busy, and we want to make optimally utilize all the resources. The scenario is, let's say the company is having a server that runs on three instances. So all the requests that comes uh, to access the server to be distributed to these instances. Now the load balancer will make sure that whatever the request comes will be uniformly distributed so that all instances will have equal amount of work to be done. You can also uh, distribute these instances on the basis of some application. Let's say there is a uh, let's say there's a university and they're having the website. The website provides the general information. Also on the website they have a page that deals with the examination information about the courses which is being offered. So based on the query, the load balancer will identify that what kind of request has been made, means the requester is looking for a examination process and all the details about the examination, or just want to see the general information. So based on that, it will forward the request to the corresponding instances. So for example, let's say we have a website www.inha.uz which provides the general information about the university, and then we have a page for providing the specific information about the exam. Let's say www.inha.uz/examination. Then we have some more information in the other page. So when depending on the request which has been sent by any of the client to access the page, the load balancer will look that what kind of application need to be requested by the requester, and accordingly it will be diverted to the server which is dealing with such application. So this is how we can divert the traffic using the load balancer. So we'll see that how the things to be implemented. Along with that, we will also see that how to uh, do the blue and green deployment with the weighted routes. So you can think about a scenario that uh, there is one application that is running on the server. So anyone want to access that application, then all the requests will be sent to the server. Now there is some modification done on this application. So there is a new version created for the application, and the company wants to make sure that the new application, means whatever the updation has been made, is uh, is is all complete, and they also want to get the feedback of the customers or the client. So uh, instead of sending all the traffic to the new application, they can make a rule that whatever the traffic comes to access the application, 80% will go to the old one and 20% will going to the new one. So we can set the load balancer that can distribute this kind of a thing, so that 80% of traffic will go to the old and 20% will go to the new, so that the company can actually evaluate the performance of the new application and can also get the feedback for its completeness. So this can also be done with the load balancer. So we'll see all the things, and uh, we will do in on the AWS platform. So this is my AWS account. I have already been logged in. So just quickly, we'll see what actually we are doing here. So we are going to create the two EC2 instances, and then we will be creating one application load balancer, and we set the target group. Now target group is to be set here. Like in the classic load balancer, we have seen that we have the instances that are running and all the and so we have the instances which are running some applications, and the request that comes to access the application will be uniformly distributed by the load balancer. So we have instances, and instances are connected to the load balancer. But now in the application load balancer, we do not associate these instances directly with the load balancer, but we keep these instances inside the target groups, and target group is associated to the load balancer. So what does it mean? Whenever any request comes from the outside, it goes to the load balancer, then load balancer will forward this to the target group, and then target group will handle these requests. Now target group may be consisting of only one instance, or there may be multiple instances are running inside one target group. So whenever any request is sent to the target group, then whatever the instances are running inside the target group will be handling that request, and then accordingly they will process the task. So we'll see how to make a target groups, how to associate the instances inside the target group, and then finally how to associate or link this target group with the load balancer. So all this thing we have to see. Also, we can see that we can also do the kind of cross overload balancing. That means we may have instances that are running in the same availability zone, or we may have instances that are running on different availability zone in the same region. So the load balancer can also uniformly distribute the incoming request to the multiple instances which are spread over multiple availability zone. In the classic load balancer, by default, this cross zone feature is not enabled. So at the time of configuring your load balancer, you have to specify that you want to enable multiple availability zone load balancing or not. But in the application load balancer, network load balancer, this is by default enabled. So at any point of time, if you want to associate or you want to distribute the incoming traffic equally or uniformly with the to the instances which are running at the multiple zones, that is also possible. So this thing also we will demonstrate that how we can do crossover load balancing over the various availability zones. So let's start. Okay, so this is my account. So the very first thing is, as I shown here, that the very first thing is we have to create the two EC2 instances. So these instances are basically running website. So we are calling as a or you can call these are the web servers which are running a website. So for the demonstration purpose, we are going to create two Ubuntu instances, and at the top of it, we are going to install Apache 2 server on it, and then we will try to make access of these instances through the browser. So whenever you want to access instances to the browser, with the help of load balancer, means whenever we are using a load balancer, then we cannot directly make a request to access any of the instances, but we make a request that goes to the load balancer, and load balancer will decide that how to forward the request, so that every point of at any point of time, the load which is assigned to these instances are are almost equal. Okay, so let's start. So first we will create the two instances. So quickly we'll create the instances. So if you have already know how to create the instances, so I'm going to keep all the things default. Just I will uh, set the minimum configuration here. So if you already know how to install, how to create the instances, and then if you know that how to install Apache server onto the instances, then you can just skip that part of the video and directly go to the part where we uh, create the load balancer. So if you don't know how to create instances, then you can just walk through the steps and see how it can be done. So click on instances and then go to launch instances. So let's say the name is server. I am going to create one instance. Okay, and I am keeping all the things default. I'll be taking the free tier eligibility kind of AMI. So here you can see the configuration what is provided in the free tier, which is sufficient for us. And then if you want to see what is the stance type, already we have discussed that there are different stance type. So if we take in the free tier, the T2 micro means this thing is given to us one virtual CPU and 1 GB of memory. And we also need one key pair because we are going to connect, uh, access these instances. So I am using a window machine. So if you want to connect with the window machine, you have to make a key pair, which is a PPK file. So here I will be already I have created one file, which is a PPK file, and uh, that key is basically used to connect remotely to your Ubuntu machine through SSH. So this is the key which I have already created. I hope that you know how to create a key. Okay, then I'll keep all the things default. Then we have to select a security group. So I will be selecting existing security group. If it is not there, you can create a new one. So in the security group, only one thing is required, that it must allow in the inbound rules all the HTTP request. Application load balancer is basically used to get the access of HTTP and HTTPS request. So it works on port number 80. So we need to make sure that in the security group. So when I say security group, basically we are uh, keeping a condition that what is allowed to what type of requests are allowed to get inside uh, into our environment network, which is onto the cloud. And outbound means who is allowed to send request from the inside to outside. So basically we are more focusing on the inbound request, that which type of requests are actually permitted to enter. So we only allow that HTTP requests are to be allowed. So in the security group, you need to make sure that HTTP port 80 must be open. So I'll keep this, and here is the default is there. I select it, and then I keep all the things minimum, or you can say the default, and I'll create the two server, okay, and then launch instance. So this is almost done. I'll go and view all the instances. So it is going to configure for us. And by the time I can rename this, I will make it as server 1 so that we can differentiate. And this is server 2. So these are two Ubuntu instances with the name server 1 and server 2. This is running, but you cannot uh, start working on it unless the status check is done. So you can see status checks need two kind of check: the system check. So I'll show you. So in the status check, we need to check system status check and instant status checks. Unless these two things are completed, you cannot start working on it. So the moment you find that status check is 2 by 2, that means your instances are properly configured and they are ready to use. Okay. So you can see all the information here, public IP, if you want to see what is the VPC subnet. So at this point of time, we are not focusing much on VPC and subnet. Later, when we talk about VPC and subnet, then we will see how this can be utilized. Okay, so go back to the instances. So still it is not done. By the time we will go and create our load balancer. Okay, so we'll go here and go to load balancer, and then you can go to create load balancer, and here you can see different type of load balancer that can be used. And along with that, this is a classic load balancer, which is basically used in previous generation. Now, before creating any of the load balancer, let us understand that this is basically for the application. If you want that all the traffic must be segregated or diverted based on the kind of specific application. So all the traffic which is basically set for HTTP and HTTPS traffic, then this kind of load balancer will handle it, um, you know, very efficiently. But if you think about a scenario where you have to handle millions of requests per second, means a huge traffic is coming, is there, and if you're expecting a huge traffic that needs the access of your server, then you can go for this network load balancer. The configuration of the two load balancers are almost the same. So we'll first look to the application load balancer. If you want to understand or read more about this, you can go to info and it will say that what exactly they are doing for us. Okay, so we'll go to create, and then you have to first give a name. So let's say this is application balancer. Okay, then we have two things are there: internet facing and internal facing. So internet facing is basically where all the requests are coming or allowed to come from external to VPC, means it can be sent through the browser. Or you can say when we use internet facing, then this load balancer are to be placed in the public subnet. When I say internal, that means you want to do the load balancing within your VPC, within your subnet. And in this case, your load balancer will be kept in the private subnet. So we are actually interested to uh, see the impact when the request is made from outside, means from the browser. So we will select this internet facing, where the client is making the request to access any of the server with the help of browser. Then it goes to the load balancer. Load balancer is kept in the public subnet. It will just uh, forward this request to the instances in a way so that all the load will be uniformly distributed. Okay, then other things will be keeping as it is default. Then uh, now select at least two availability zones and one subnet per zone. Okay, so here we have to select that load balancer should uh, divert the traffic to which of the availability zone. If you are very sure that your all the instances are to be kept in a particular zone, then you can select any of that particular zone. Otherwise, if you select every zone, then also there is no harm. You can select everyone as well. There is no harm into it. Okay, let us select all these: A, B, C, and D. And before this, let us also verify that what are the availability zone we have used to instantiate our instances. So let us go here as well. We go to EC2 and let us check that where they're deployed. So they're actually deployed in US East 1B. Okay, this is important to know that our instances are running in this availability zone. Okay, going back here. So already we have chosen US East 1B. That's fine. Okay. Now the meaning here is if I enable A, B, C, D, that means this load balancer is able to do a crossover load balancing onto the regions which you are selecting here. So if I select A, B, and C, that means if my instances are running on these availability zone, then this load balancer is able to associate all the instances which are running on these availability zones. So we have selected A, B, and C. So that means if I create any of the instance in C region, then this load balancer is also able to manage the instances which are running in C, B, and A. Okay, so we keep all the things as it is default, and security group we will keep the default one, and then this is okay 80. Now we have to when we create the load balancer, we have to create a target group. So target group, you can create a target group from here, or before you start creating your load balancer, initially you can just start creating a target group. Both are same. Either you can create a target group first and then go to load balancer, or you start with the load balancer and within the step you can create your target group. So as we have started directly creating the load balancer and we have not created any target group, so here itself we will create our target group. So target group, because at this point of time we don't have any target group, so first we have to select and create a target group. Okay, so this is to create a target group. Now, target group, we want to keep instances in the target group. So actually, we have two instances running. So what is our strategy? We are keeping one instance in first target group and other instance in the target group. Okay. So we select instances here, and then we just keep target group name. Let's say this is target one, so that we can distinguish that this is the target one. The other things keep default. So no, this is a health check path. So it will make sure that the default path is defined or not. So one thing to note that load balancer will only forward the request to the instances which are healthy. Okay. So this is for the healthy. We have given two parameters that it must check that this HTTP uh, ports are open and also a defined path is specified here. So it will go to default path, and the default path there must be the default page existing, that is index.html. Okay, next. Now it will ask that in this target, so we are going to create one target group. This is target group one. So it asks that we have two instances running. Do you want to associate any instance in the target group? I say yes. The first server should be kept inside the target one. So click here and create a target group. This is done. So we'll create another target group and we'll keep this everything same as it is. We'll name target 2 and these things are same. This is all same, and then you click on next, and then it will say that do you want to associate any of the instances in this target. So I want to keep this instance number server 2. Click on it and then create target group. So we have created two target group. Target group 1 contains instance 1, target 2 contains instance 2. So we'll go back here and then you can go to load balancer. Now here you can see, so now if you click here you will find that target groups are visible. You can just refresh here and target group are visible. So let's say I select target 1 here. Okay, and just keep all the things default. Okay, that's it, and create load balancer. View load balancer. Now you can see that load balancer is visible to us. It is still not ready to use. It is provisioning. Now we have selected 4 availability zones. That means this load balancer can be applicable or can be applied to the instances which are running on these 4 availability zones. Okay, so let's go here and you can see more information here. Now we can also uh, look to this. As I said that we have this option is available here, blue-green deployment, where we can uh, make a logic, divert the traffic as per our requirement. So I want that uh, load balancer will divert 80% of the traffic to target 1 and 20% to target 2. So Now, before this, we have to make sure that both the targets and instances are active. Then only it will be visible to here, uh, visible here. Okay. So we'll go to target group first. We'll go step by step. Now you can see target one. It is already associated with the this app balancer. So that means only first instance is being linked with the app balancer, but target 2 is not yet linked with the any of the load balancer. So we have to associate. So just click here and you can associate with the existing load balancer. Okay, this one. Go to listeners, and here we have to select this, and then we have to go here and then go to edit listeners, and then we have to go down, and then you have to select target group 1 is already been added with this load balancer. We have to select target 2 as well. Now this point of time, it means 50-50 means if two requests are sent, then it will be distributed uniformly. So we can just make it like this. Now if this is a scenario, if you make 4 requests, then 3 requests will go to target 1 and 2 requests will go to uh, 1 request will go to target 2. That's a 25%. Okay, let us just explore more options. So if you look at this, if I am going to make 8 requests, then 75% of requests go to target 1 and 25% request will go to target 2. So this is what I want to keep. Okay, then click on save changes. Okay, so we have add the listeners. That means basically we have actually uh, added our targets and associated it with the load balancer. And this is the rule that we have fixed, that 75% request will go to target 1 and 25 will go to target 2. Okay, so I hope everything is now done. We have to check the status, means health status about the stances. So we'll go to the target groups, and you can see here that both the target is now attached or associated with the load balancer. Okay, and if you go to specific target one, so you can see the health, it is unhealthy, it is still not ready. So we will wait for some more time. Okay, by the time it is going to configure, we'll go to our EC2 instance. Okay, this will close, it's not required at this point of time. We'll go to EC2 instance and see the status. So EC2 dashboard, we have the instances running here, and it is not yet ready. Okay, now this is ready. So now our instances are ready to work on. So if you look to the server one, and if you get this public IP, and if you want to access it from here, you will not able to access because this instances does not have any server onto it. There is no server running. So we have to install server onto it, and then we can able to access through the browser. Okay, so we have to use putty here. So we will use putty. Okay, so let's go here. I want to first connect with server one. So I'll go to instances. This is server one. I'll just select this public IP and then go to putty, then connect remotely to my Ubuntu. For this, I need the credential to supply. So I supply my key. This is my key, and then click, and it says okay. Okay, so let me just make some changes here so that it can be visible to us. Appearance change, make it 16. Okay, so now for login we write Ubuntu, and it is done. You can, so first you just update. So you can write sudo apt get update. Okay, so it will make your system ready. Once it is done, we need to install the Apache 2 server so that we can access to the browser. Okay, it's done. Then we write the command sudo install Apache 2. Okay, so this is installed. Once it is done, we can just cross check that is it working or not. So we'll see that the index page exists or not. So that the default directory where the index page exists is this is where www.html. Here we write the list command as, and it shows that index page is existing. So we'll go to this IP and then we refresh it again, and now the page is accessible. The same thing we will do for server 2 as well, but because the we are installing the Apache web server, so the the default page is same. So in order to differentiate that whenever we make a call, for example, if you want to make a call for server 1, and because both are running the Apache 2 server and the default page is same, so it will show you the same output. So just to differentiate that what kind of call is being made, we will just change the web page so that whenever you make a call, we can differentiate that, okay, this is server 1 is being called or server 2 is being called. So we'll go here and then we will just delete this page and we will create our own page. So we'll delete this sudo remove. So rm index.html, and if you now there is no file existing, so now you can write sudo nano command is for creating a new file index.html. Okay, so you can write this is server 1. So this is just an identity or a kind of mechanism through which we can identify. You can just press Control S and Control X. So this is done. Now if you again press LS, you can see the index file is there. If you want to see the content of this, you can write uh, get index.html. So this is visible to us. Now again we go back here, and if we refresh the page, we can see that the page has been changed. The same thing we are going for the server 2 as well. So I'll go here and go to instances, go to server 2. You can just exit from here, and again server 2 you just this is a server 2. Okay, so you can just copy this and then you can go to putty and then connect to default name is Ubuntu. Let us first change the font size so that it's visible to you. Okay, so we'll do the same thing. Sudo apt get update, and once it is done, we will be installing the Apache server. So it will take some time. Okay, it is done. So we'll just make a new screen and then you'll write again sudo. Okay, so this is done. And again, if you want to cross check, we can go here and we can write this, and this is available. So again, we will do the same thing. We will just remove this page. We will write sudo rm index.html. Okay, so this page is not available because we are in the default directory. So we have to go to the directory. So we'll write sudo where. So if you see this file is shown to you, now you can just delete this. Okay, now we check. This is not visible here. It's already deleted. So now we create a new one. Sudo mm, you know. So we'll write here. This is server 2. Control S, Control X. This is done. You can check this sudo cat index.html server 2 and then exit. So now if you refresh this page, you will find that this is showing you server 2. Okay, so our two instances are complete. Now the server, Apache server is running on it. Now we have to uh, use load balancer. Now go to load balancer. This is load balancer. Okay. Now let us check the status that whatever target group, inside the target group, we have to see that the instances are healthy or not. Because if the instances are not healthy, then they will not be assigned by the load as balancer. So target one, it is healthy. This is ready to take request. Okay, then we will go to target group 2 and see the status. This is unhealthy. Okay, so this is now this is healthy. It's just shown healthy here. Okay, it is healthy. So both the instances are healthy now, and both are able to take the request from the load balancer. So now what is required? We go to the load balancer, and then here we will get the DNS. This is the DNS name. We copy here. Now, whenever you make any request to access any of the instances, whenever you send any request to the server, then it goes to the load balancer, and load balancer will send or forward the request to these instances. Okay, so I'll go here and I will use this DNS, and I will, so it is showing server 2. Okay, then again I will refresh it. It shows server 1. So I make two requests. Then this is request number 3. Again the same thing. Request number 4. Again the same thing. Request number 5 is server 2. Request 6 is server 1. So I have made 6 requests. So out of 6 requests, 2 requests is diverted to server 2 and 4 requests is diverted to server 1. And this is what we want, because we have made a criteria that 75% requests should go to server to server 1, and 25% will go to server 2. And this is how we have seen that the load balancer is doing the job perfectly. Now in order to uh, see this part. So what we have seen up to now, we have created the two EC2 instances we have created. Then we have created the load balancer. We set the target groups. We have associated the load balancer with the target group, and we also send the request to the browser. And we have observed that the load is perfectly distributed among the instances as per the criteria set, that is 75%, 25%. Now we will be going to demonstrate the load balancing over the multiple availability zones. So now I'm going to create another EC2 instance, but this instance will be in the other zone. So this instance, as we have seen, it is running, I think it's in US East B zone. Now we'll create another instance which is in C zone. And then we will be using the same load balancer and distributing the load. Okay. So I'm going to just a minute. So I'll go back here. I'll go to my EC2 instances. Okay, and let's say this particular tab is keep for the load balancer. Okay, no problem. This is for the EC2. So I'll go to the EC2. I'll see my instances. Now these instances are actually in US East 1B. So now I'm going to create another instance which will be in the same region, but it will be in the other availability zone. So you can see here, all the information is actually here, shown here. What the key you have used, what is the DNS name, what is the availability zone. Okay, so now I'm going to launch one instance. Let's say this is server 3, and I'll keep all the thing default. This is again the Ubuntu machine. Okay, and I'm going to use the key pair which I already have created, key 1, and then I use my default security group. This is default security group I have used, and then I am going to keep other things default. Okay, I want only one instance, and then launch instance. You can go here. So server 3 is now going to initialize. Now one thing you have to cross check that I have used the default security group, and in my security group I have already set the condition that inbound rules is actually allowing the HTTP request that runs on port 80. So you just cross check that inbound conditions are set correctly or not. So let us, how to check, you can go to, let's say, this server 1, and then you can go to security, and then you can go to the security. You can just go here and click here and go to edit inbound rules. So in my case HTTP is already enabled, but if you are not able to get the request, means if you find that something is not going properly, you just cross check that your security group is permitting this inbound, means in the security group your inbound is properly set or not. So this is to be required. If HTTP is not shown in your inbound rule, then you have to just add rule and select HTTP, and then just click on save rule. Okay, that's it. So going back here, we'll go to instances, and we'll see that this instance I have created in availability zone E, and but this is to be only utilized when our load balancer is also enabled in E. So we'll just cross check that what is the status of load balancer. We go to load balancer, and this load balancer is basically running on 4 availability zones. So what are the zones? This is A, D, C, B. It is not in E. So that means we are not able to use that instance to be managed by this application, this load balancer. So we need to, okay, we'll do one thing. We'll just quickly create one more instance in either of these zones, A, D, C, or B. Already we have in the B, so we'll create somewhere in A, D, and C. Okay, so we'll go here. EC2 instance is running. We'll just stop this. It's not required this time, so we'll just stop this instance and we'll create a new one. Okay, we'll name this server 3 and then select Ubuntu. The rest things we keep as it is. This is keep here is key 1. Now here we have to check. So here the subnet. So here I have set no actually preference is given. So no preference means by default, it will just assign your instance in any of the availability zone. But because we are very specific, we want to make sure that our instance does not be created in availability zone, because our load balancer is only linked with only four availability zones. So we'll go here, edit, and then we will set that I want my instance to be created, let's say in A. Okay, okay. So I select this A, and rest things will be kept as default. Security group is a default which already we have used, default one, and okay, other things will be kept as it is. Click on launch instance. I think this time all the things are done as per our requirement. Okay, so you can see that this time this server 3 is actually created in A. So now you can see that these instances are in the different zone and this is in different zone, and now we can distribute the incoming request to the instances which are distributed in the different availability zones. Okay, so let us just delete this one. This is not required. We will terminate this. Okay, so now we have these three instances are there, which is running here. So now we'll go back to the load balancer. Now we have seen that we cannot directly attach the instances to the load balancer, but we are attaching the target groups to this load balancer. That means the instance that we have created must be within some target group. So now we have one option. Either you can make a new target group and then add that instance into the new target group, or you can add the instance in any of these target groups. Okay, so how we can do? Let's just create one new target group. Let me again repeat what I am saying. I can add my instance in any of the target group, because target group is just a collection of instances, and it is not mandatory that all the instances must be running in the same availability zone. These target group can have a collection of instances that may be running on different availability zones. So now what is the option available to us? We can either create a new target group, and that target group will include our newly created instance, or you can add that instance into the existing target group. So you can do anything. Let's say I am going to make uh, a new target group, let's say. Okay, okay. So new target group I am making here, and we have already seen that how to make target groups. So I'm doing first target 3. Okay, things remain same. Okay, this is same. Okay, next. Now we have to associate what instance I want to keep in this target group. So I want to keep this third one, and that's it. Okay, and create a target group. So we can start sending a request once, and we will make sure that our instance is in healthy state. So now this target 3 is having one instance, but this target 3 is not yet linked with any of the load balancer. So we have to associate this load balancer here. So you click here and you can associate with the existing load balancer, which is your application load balancer. So you can just go here and go to listeners here, and then you can edit listeners here. You can find it here, edit listeners, and then you can add your target 3. Now you can just make a rule that if I am going to make eight now at this point of time, the distribution is 22% request will go to target 2, 6% will go to target, sorry, 66% will go to target 1, and 11% go to this. So let us make some changes here. So if I make like this, then 20% is to target 2 and target 3, and 60% is to target 1. That means if I make 10 requests, then 6 will go to target 1, and 2 will go to target 2 and target 3. This we have to see. Okay. So again, just check. 6 will go to target 1, and the remaining will go to target 2 and target 3. Okay. Okay, done. Now, one more thing is actually left here, that in our EC2, this is in our this instance which we have created just now as a server 3. Now the server 3 is actually created, but it does not run any server. So let us install a server quickly to it. So for that we need to do the same exercise. This is the public IP. We have to go to PuTTY, and then we have to connect. Okay, so we'll do it again the same way. Just let me change this little setting so that all the things are visible. Okay, okay. Now this is better view here. Fine. And so I will write sudo apt get update. So the same step I am going here, but now in this case I'm not going to change the default page. So now we can easily differentiate server 1, which has a web page server 1, server 2 has a web page server 2, and server 3 will have a default page that we see in the Apache. Okay, so now you can just clear the screen and you can write sudo apt get install Apache 2. Okay, this is done. So in order to check, we will have to, at the same time, we will just go here and just quickly, this is your server 3. We will copy this, and once it is done, this is done, we can go here and access this. And you see, this is basically your server 3 machine, which is showing this web page. Okay, so now I think all things are done. Now we have to demonstrate. So let us check the status of the target groups. So these are target groups. Let's see the health status. Target 3. So this is unhealthy. Let us check the status why it is unhealthy. Okay, we have to wait for some time. Let us let it configure properly. By the time we'll check for the other target groups. So if target 1, this is healthy, and target 2 is also healthy, but target 3 is not yet properly configured yet. Okay, uh, let us check more things. Okay, now when we say healthy and unhealthy, so how it is determined? So normally the load balancer actually communicate with these instances, so it will send a message, and if it is acknowledged within a defined period of time, then the balancer assume that it is healthy. So if there is no response coming from the stance, then immediately it is assumed unhealthy no. So we have to set a rule that if you get two, if the load balancer send two requests, and if there is no reply for the two, if there is no acknowledgement for the two consecutive requests, then it is assumed to be unhealthy. and how it can assume to be healthy. So uh, whenever any of the instance becomes unhealthy, then we can set a rule that you can make you can send a three request or four request or five request, and if all the five requests are acknowledged immediately, then it is said it is assumed to be healthy. Now, how we can set the rules? So you can go to health check, and in the health check you can go to edit, and you can just set all the rules that how much is the threshold for the health check, means how much time you have to wait that instances are assumed to be healthy and unhealthy. So all the things we can set it here at how much time it has to wait. So we are just keeping all the thing default, but if you want to make some changes, you can go here and do the required changes. So I think it's all healthy now, and so we'll go to the load balancer, and then you can see the DNS. Okay, and then we go and use this DNS here, and then run this. So this is your web server 3, request number 1, request number 2, request number 3, request 4, 5, 6, 7, 8, 9, 10. So we have seen that when we made a 10 request, the 6 requests goes to server 1, 2 requests gone to server 2, and 2 have gone to server 3. That means the load balancer is doing its job perfectly and as per the setting we have made. So uh, this is how we can do or configure the load balancer. So I believe we have did all the things as per the requirement. So we have done this exercise. We have created one more instance and the other zones, and then we do the crossover load balancing for the multiple zone. So this is all that we want to see in this demonstration. And one thing to keep in mind that before you complete your work, don't forget to terminate all the instances. So because this is chargeable, so you have to make sure that after doing your work, you just terminate all the instances. If you feel that you have not completed your exercise completely and you need to do it again, then at that point of time you can simply stop it, because when the instances are in the stop state, then also they are not chargeable. So if you feel that you have did your completed your exercise completely and now these instances are means not to be used, then you can delete it. It's better to delete. That means you can terminate it. But when you terminate it, it is not immediately removed from your screen. You will find the status terminated. For example, when you see here, it says stopped. That means it's not running. So when you select terminate, it will say terminated, and it will remain the status same, and it will show onto your screen for the next 1 hour, but the instance has already been terminated. But after 1 hour, when you log into your account, you will find that it is not visible here. Now to remove the load balancers, so if you directly delete this load balancer like this, we'll check this. Okay, it is done. So that's fine. We can go to target groups. If we delete these target groups, so it is done. It is fantastic. So if your if your instances are running and if you want to delete any of the target group or load balancer directly, so it will not allow you. First you have to remove the listeners. So you go to listeners and then you just remove listeners, and then you can remove the target group. This is all for this exercise. Thank you very much.